All right, we're going to look at some angle relationships, and we're going to start with some basic ones. The three angles of a triangle, hopefully you remember, add up to 180 degrees. So if you were given two angles in a triangle, you'd be able to figure out the third angle, because the three angles of a triangle, when added together, always have to equal 180 degrees. All right. Another thing that we learned this year is that if you had a triangle and you were asked to find this angle out here, this angle out here is the same as those two angles added together. So the reason why is that these two angles right here, I'm going to number them, angle 1 and angle 2. Oops, sorry. Angle 1 plus angle 2, those add up to 180 degrees. And then if I look in this triangle right here, I'm going to call this angle 4 and this one angle 3. Angle 1 plus angle 3 plus angle 4, all of those have to equal 180 degrees. So if we use a little bit of thinking here, angle 1 and angle 2 have to be 180. Angle 1 plus angle 3 and 4 have to be 180. So if I remove angle 1, I know that angle 2 is going to end up being the same as angle 3 and 4 added together. So that's a little bit of a shortcut that you can do depending on what angle you need. Other angle relationships that we're going to look at are the ones that are formed when we have parallel lines. There's a lot of vocabulary words here, so I'm going to try and do some color coding. But first, we start with parallel lines. So I'm going to use the lines of the paper. And this line right here is called the transversal. And anytime you have a line that crosses parallel lines, that's called a transversal. So if we look at this, I'm going to number all of these. You know what? Actually, I'm going to use letters. So A, B, C, D, E, F, G, and H. And if I look at the angles that are formed, when you look at this picture, you should see a lot of acute angles, like those. And then you should see some obtuse angles, like A, D, E, and H. And what's going to happen here is that all of these angles are related, but they're related not only to each other, but also in numbers. So we're going to start off by saying that angle A and angle E, those two are known as corresponding angles. So those, sorry, pen's a little messy there, are corresponding angles. And what I usually teach is that they're on the same corner. Different intersection, if we were to think of these as roads, this is a different intersection right here compared to this one, but they're on the same corner. So different intersection, same corner, those are corresponding angles. So A and E are corresponding. Looking at the other ones, B and F are corresponding to each other. D and H are corresponding to each other. C and G are corresponding to each other. And what happens is if we know the measure of one of them, the other angle is the same as long as the lines are parallel. So those are called corresponding angles. Some other ones, alternate interior angles. That's talking about angle C and angle F. And alternate because they're on opposite sides here. So here's this line. C is on the left, F is on the right. So that's where the alternate comes in. Interior because they're inside the parallel lines. So these green ones are alternate interior angles. And the relationship that they have is that they are equal. Congruent means equal. Those are equal angles as well. And same thing with E and D. Those are also alternate interior angles. So you can probably guess what's next, and that is alternate exterior angles. So an example would be B and G. because they are alternate because they're on opposite sides of this line. So G is on the left, B is on the right side of the transversal, and exterior means they're outside of the parallel lines. So those two that I marked, B and G, are alternate exterior angles. And those two angles are equal. So if B was 50 degrees, so is G. Also in this picture, A and H would be alternate exterior angles. All right, we also have some angles on the inside, and these are a little different because what's going to happen here is that these are not going to be congruent or equal angles. We're talking about D and F. So if you look at, if you look at angle D and angle F, they're on the same side. So they're not alternate interior because they're on the same side. So you can use the same side interior, or another word is consecutive. And consecutive means that they are right next to each other. So same side or consecutive interior angles. Now, these are not congruent. If you notice, angle F is acute, angle D is obtuse. So the deal here is that these two angles will add up to 180 degrees. All right, we have one more special vocabulary word or set of angles that we want to point out. And those are vertical angles. And vertical angles are ones that I refer to them as a bow tie. If we just look at this one set right here, I'm going to use H and E. Those two angles are vertical angles. They have the same vertex. That's why they're vertical. They have the same vertex, but one of them is going up, the other one's going down. They could also be G and F. G and F have the same vertex. One's going to the right and one's going to the left. So those angles right there in orange are called vertical angles. And they are special because vertical angles are congruent, which means they have the same degree measurement. All right, the way this works is this. You could be asked to identify a pair of angles as being vertical angles or alternate interior or alternate exterior, or you could be even given a measurement. So let's just say that angle A, I'm going to say angle A is 120 degrees. If I know that angle A is 120 degrees, I can tell you every other angle on this, every single angle on this picture. And the reason is because A and E are corresponding angles. So that means they're the same measurement. I know that E and H are vertical angles, so they are the same measurement. And then I know H and D are corresponding angles, so they're that same measurement. I could also have said that A and D are vertical angles, so they're the same measurement. But in the end, all of the obtuse angles are the same degree. And that only happens because these lines are parallel. So now let's say we want to figure out the other angle. That one you just need to use some math that you learned last year, and that is that anytime you have a straight line, those angles have to add up to 180 degrees. So if this angle right here is 120, this angle right here has to be 60 degrees. So then if that adds up to 60 degrees, you can look, these two angles right here also have to add up to 180 degrees. And so do those two angles right there, C and D, have to add up to 180 degrees. But we can also go back and use this vocabulary down here. So lots of different ways to figure it out. B and C are vertical angles, so they're going to be the same degree. C and F are alternate interior angles, so they're going to be the same angle measurement. And then B and G, remember those were alternate exterior, so those are both the same measurement. So now you can see that the angles that are corresponding have the same degrees. The alternate interior angles have the same degrees there and there. The alternate exterior angles have the same degrees there and there. The vertical angles have the same degree there, 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 there. And then the same side interior or consecutive interior add up to 180 degrees. And then at any point that you draw a line, you have angles that are referred to as supplementary angles. And hopefully you remember that supplementary angles are angles that add up to 180 degrees. So supplementary means that it will equal 180 degrees. So those are some of the important angle relationships. Triangles add up to 180 degrees. You can use a little bit of a shortcut with figuring out the angle outside, and then all of the vocabulary words that go with parallel lines.